Okay, hello. My name is Jack, and
Hi everyone, my name is Songjia.
yeah, for those of you who are in our module, of course, you know who we are. This live stream or this live stream that was recorded and edited is part of the module for developing immersive applications. So this stream, right, recorded stream, we are going to introduce various ways of implementing interaction mechanics. So it includes different methods like using actions versus using behaviors, and also including using coroutines to implement these methods. And in this lesson, to focus on interaction implementation, Songjia will also show some little tidbits about how to organize code. As with that, let's dive into the coding session.
Yeah, sure. From the last tutorial, so basically we have done some code refactoring, so just put things in functions here, or we should say as methods here. So next thing, for this tutorial, we'll not use everything here. So we basically need to just clean up this thing a little bit. Alright, so we do need a camera, we do need the lights. Yeah, we need a sphere. Do we need a model? Okay, maybe we don't need model and sound. Maybe text. Maybe we use text. Skybox. Shortcuts. Maybe we can use some shortcuts. So now we have a simple sphere here, right? So we'll keep that. So I will take this as an example. For example, we have the create text here. So I will show how JS break code into multiple file, and you can load the code from another file into the app.js. Sorry, app.ts.
Sorry, hold on. I just thought about something that a lot of students were asking. I'm not asking, but had problems with the npm run serve, right? So maybe you can tell us the difference between that and just now what we did to deploy in the dist folder.
You mean
Yeah,
these two different
I know.
npm script?
Basically, just now we ran the code in the dist folder by running a Python server, versus now we are in, our development directory and using npm run serve. What's the difference between those two?
Okay, so the npm run build will just bundle everything together as a distributable, and the run npm run serve will just set up the will start a dev server by Webpack, provided by Webpack. And every time you change your code, it will detect change of your code and rebuild your app, of course, as the development build, and reload your page. So it's kind of like for development, it's much easier. Instead of you every time you change something, you have to build your app as a distributable, then use some external server to log the result. So it just makes things easier.
Yep.
So
Yep. So in summary, if you want to distribute your project as something that somebody else can serve or somebody else can run, right? You need to do npm run build so that the files in the dist folder are actually runnable independently of the rest of your project. But if you are in development and you want to easily look at changes in the web page, right, while you are changing stuff, then you do npm run serve. And the words build and serve as what Songjia is showing here are all set by yourself. It's just that I think most of you have followed what Songjia's names are. So most of you are using the same npm run build and npm run serve. So just highlighting this because we found that a lot of the distribution folders have non-working HTML code due to the fact that you did not, probably you did not explicitly run the command to build the files. Yeah.
Yeah. Yes. So when you want to distribute your app, you need to build your app, and because every time you run, the npm run server, it's actually build your app, then actually put that in the memory. It's not really save that on your file system. So if you want to distribute your app, you need to build it, and also the npm run build. I mean the webpack, the things I showed in the last video about the integration. So it will also do some optimization for your app, like make the code the app size smaller, and do some optimization, to also do some work for you. And also you can have multiple build configuration. For example, you can have a configuration for build your app as an extension, or build it as a standalone app. So you can have multiple build scripts here. Okay, but you can always use the serve to develop your app, and can build it to a multiple platform or in multiple formats. Okay.
Okay, cool. All right, let's get back to the interaction code.
Okay. All right. So here, what I will show here, and I text. Okay, so I will move this part of the code into another file, and import the code in the second file into this app.js. App.ts. So kind of you are making a component, okay, for your app. So, okay, so a custom component. All right, so let's see. Okay, let's go back to source. So far we have I don't feel like it's particularly useful. I mean all the .d. Yeah, I think just things really. If you are making some library, the .d.ts is very useful, because it's kind of like people know the API. But for the standalone app, maybe just we don't really need to use that. So if you don't like too many files here, you can just remove the .ts file, and I think it can just okay. And coming out this one, this option is give you all the declaration files. Okay, this option depending on your own preference. All right, so so we will make components directory, and okay, so the text. Okay, also we have meshes. Okay. All right, so we add more, add two directory. So we get components meshes here. All right. So I will create two folders here. Sorry, two files here. One is called index. I think just ts, and also another one is what we call give a name to that.
You mean the component name?
Yeah. So
It can be any name, right?
can be any name.
Yeah.
So we maybe can just call it because it's a plane with text. Maybe it's a not good name. I just call it the text plane. Okay. So
Okay.
basically, you can see we have a plane, right? Then we have a text as the texture of the plane. So I just named this as a text plane. So later on, you can use this one to show some text on the screen. So yeah, I just named this.
Yeah, always good to have intuitive names. Yeah.
All right. So first, we can post things here. So basically, we can just for sound. Okay, maybe sound not really that we need. Okay, so this part actually is creating the text plane. So we can move these things, and the rest of actually is the behavior, or not behavior. I think the interactions we can have on the text plane. So actually, we already used some interactions on the objects in the previous tutorial, but we will give more details about these techniques.
Yep.
Okay. Okay. So first, we can post things here, but okay. So we can create a class. Okay, so you can make multiple instances of this class. So we also want to external module to use this class, so we can just export class. We can name this text plane. Okay. All right. Then we can just put everything here. Okay. Right. So we need to add the constructor here. Okay. Sorry, these all things we can put into the constructor. Here. Ah, nice. Okay, so we can see something is missing here because we need a mesh builder. So it's from Babylon.js. So we need import Babylon.js here. And also we can put input Babylon.js GUI, right? So we need these two here. So there's a small trick here. You can press depending on system, so command dot or control dot, it will give you the quick fix. So here, because we are missing two imports here, so we can choose add all missing imports here. So it will, or even three, okay. So it will automatically insert all the imports for you. So okay, a small trick for you use.
It saves a lot of time.
Yes. Okay. So next thing we will rewrite the code, not rewrite, but just do some adjustment. Okay, to do this to make this part of the code as the constructor. All right. So let's see. So now this is not hello plane. It's a more generic text plane. So we just can rename this as text plane. Then we have build. Okay.
There should be a refactor command, right? So that you can change all the same name variables
Yeah, there's
but not sure
something there. But normally I just use Wings.
that will work as well. Just, yes,
Yeah, just replace everything here. No.
sure.
Yeah, but there should be some refactor functionality from VS Code or any IDE.
Yeah,
But I normally just rely on too much on Wings, so I don't really know the
sure.
the
As long
shortcuts.
as you are as fast as the refactoring. Yeah,
Okay.
not important. Okay, important when you do a lot of refactoring. Yes.
Yes. Okay. Then we probably will give a proper name as a text plane, right? And also because I think it's better to give the name. Okay. So for the constructor, we can have a name parameter here. Then I can put the name and okay. Yeah. So give the unique name for probably unique. I hope it's unique, but for the text plane. So wherever you give a name to the text plane, it will name this name down, then have text plane to indicate that's where this from. Okay, so I think we have probably this add more. Okay, number. What? Okay, I think. What's right? Yeah, I just quickly put everything here. Maybe you can figure out a better signature for the constructor.
Oh,
Do we have a spelling checker here?
yes, spell checkers are also useful.
Okay. That's the most popular one. Code spell checker, okay. Alright, so we got the class. So we need to import the class from this file. So here we call there's a mesh directory, which means we have multiple. It's called meshes, right? So we can have multiple mesh classes here. So it can be multiple files here. So index here, it's kind of make it easier for you to import. Instead of you import the single, the individual file here for maybe multiple meshes, you can create a index.ts here. You can, this is a purely for management, so organization. So you can export everything from the text plane here. So if later on you have more files, you just add more export here for like if you have another, for example, another plane, something like that. So as long as you have the exports here, okay. The next thing, let's go back to apps here. Okay, so whenever you import from components, right, and meshes, you just need one import statement here, and everything you export inside this folder, you can just simply import in this one single statement. For example, we have text plane here. Okay. So later on, I can add more meshes into this directory, but you don't need to have multiple statements. You have just one statement to import all the meshes, the custom meshes you create for your project. So pretty much just feel like the one thing similar style for the Babin.js. You just one import and get multiple classes here. All right, so let's go back to
Okay, cool. So in summary, yeah, you can continue typing.
Okay.
What Songjia has shown is just a typical and simple way to organize your code. aka your code architecture in a simple component-based method. So I think some of you may also have glossed over, code organization. So I think at this point it is a good time to make sure that all the new code that you are writing follows a certain nice code organization. Yep.
Yeah. Okay. So now here we want to create the hello plane, right? Okay. So we can name as the same hello plane. But instead we create everything by ourselves, we can just use the class we have create. It's called text plane. Yeah. So I need to give all the parameters it's needed. It's okay. So first it's the name, right? So we just give no. Oh, I think we need a thing, right? That's the okay, yeah. And for branches, the thing is object. It's optional, but I feel like it's better to specify. Okay, then we can safely delete this one.
Okay.
Or just comment this out. Maybe just
Yep.
comment this out.
That is so much cleaner. I think we can delete.
Okay, let's see. Just make sure it's working.
It's definitely not. There's no way you type so much code it will work. Cannot find name hello text. Okay, let's look at
hello text.
211. Okay. Oh, it's not.
Oh, okay. This is the error here.
Name, yeah. A different name now.
It's not exactly the name. So because we add the interaction, it's not on the hello plane. It's not on the plane. It's on this here.
Yeah.
It's the control of the plane. It's hello text.
Okay. So where should we add this code now?
Yeah. So that's really good question. So let's go back here. So basically we need a public field here. Okay, then we just call the text. Right.
Control?
I don't know. Control plain text. Text plain and plain text, or just text. What's the type of it? Maybe just use a block, a text block. Maybe just use the. What's wrong with that? Why is just no? Do I have any? Okay. Cannot read the property of undefined.
Because the text block is undefined.
Let me see. Why isn't it?
So
oh, okay. Yes, of course. Okay. My bad. So after I declare the public property here, I need to assign a value to it, right?
Yep.
Okay, so after this dot text, yeah, it's very common mistake. So what's the name of that? Oh, plain text. Okay, this should work. Yeah. Okay, finally.
Okay. Good.
Good. It's just okay.
We can just leave it here.
Okay, and just should be fine. All right, then we can safely delete the code here.
And that is how you would convert, a piece of code into a component.
Yeah. So basically, we just made our own component, text plain component. So you the same way you can break your code into different components and make the app.js. I mean, the main script and much more
manageable.
Yeah. Okay, so you can do the same way for like animation, particles. Yeah, I just don't really show here. You can just work out by yourself. Okay, so basically in the tutorial, basically just use two spheres to show all the interactions.
Okay.
Probably I need to adjust this one, the label here a little bit. Okay, so as a displaying to show some information from the interaction. So
Okay, so with the magic of video editing, let's skip to after you have refactored this.
all right, so this is one sphere we will use. Maybe that's the simple sphere. And okay, a simple sphere. We will use another sphere. Okay, so we can call it the hello sphere. So it will be a sphere with a text label on that, and we can use this class to show how to use interactions with actions. Okay, so this is the second custom mesh we can create. So it will be built based on the text mesh we already have. Then after that we can just okay, so that's the hello sphere and hello mesh. Yeah, so why we create the second one? So the text plane is the very simple example here. You just create your own class, and for the mesh plane here, oh sorry, the hello mesh here, so it's a bit different. So we will try to use the interface and also extend the existing class from Babylon.js, so you can utilize some method or property already there, and from the class. So the class we will use is called the abstract mesh. So first we can create the class. So we can just call this hello sphere. Just so it can extend abstract mesh. By this way, you kind of making a subclass of the abstract mesh. And also, since we can also create the interface. So for interface, it's kind of like a head file for in C++. So the public properties or public fields and also the public methods there, and implement that in the class. But it's not something you have to use. I just use the interface here because I just want to just show you how to use it. Okay, then just hello mesh. So later on we will declare the public. It's better to export to because it's the interface. So later on we can. So again, so you can have multiple class. We can have a hello sphere extended abstract mesh, and also you can have other class named as hello cube or hello something. Then you can also implement the interface. Then all the hello related mesh will have same public interface. Okay, no matter it's extend abstract mesh or other class, they both have the same interface here. So the syntax here, so after you extending the existing class here, so also to use implement the interface here. So we got everything here. So first we need to have instructor, right? So as usual. So because you are extending the existing one, so the first thing you need to call super. So that's the super, the constructor of your super class. The two things we need to have here is the name. Okay, it's required by the super class, and thing is optional, but we still want to use. Okay, so again, so basically you need to pass the parameter here. Then you have an instance of the superclass. Then you can do the rest of things for your own class here. For example, if we want all the hello mesh have a public field here, we can have the theme, for example, and have the theme. So if we say, okay, it's complaining because you implement the interface, so you have to have a field here, the box here. Okay, so we can just give the theme equals to the arguments we got here. That's one thing we can have. So because we want to build a hello sphere, so it needs to be a sphere, right? So here, if you want to follow the Babin.js naming or signature convention, you can use the option object here. I just show this simple. So and give the object here. So this is something very different from C++. So we have the parameter here. It's called options, right? So options is actually just it's a JS object here. So without any class definition, you can directly give object here. Yeah. So the property of the project we can have one. We just save the time. We just give the diameter here. Okay, and we use this diameter option to create a sphere. Okay, so it's called the hello mesh. So it's better to expose the mesh, the actual mesh, here. And then this child, because we inherit from the abstract mesh. So abstract mesh is kind of like it don't really have a mesh, but it's kind of like a group object for the for meshes. Okay, so we can just add the child. So we already get the sphere, right? So the child is be this mesh. Okay. So next thing we also, because we have mesh, we also have a label here. So we can have label here. So it should be a text plain. So this is our custom. Then okay, then it should be implement here. Text plain. All right. So here we can create the label. So it's kind of kind of like a component based on another component you have created.
Yep.
So again, group component together. Okay, text, hello, sphere, maybe label. Maybe it's depending on you. You can name this or even just don't give the name. I feel like it's better have a name, so it's much easier for you to debug if you use you are using the inspector, because you can see the multiple nodes there. So you do have the name. So it's based on the unique name. You can know which one is which one. So it will be much easier. So let's see. It's this is the XY. We got the option dot diameter. Yeah, basically that's just the size and the position we need to make it to shoot correctly. Okay, that's the set. And then we can add child, right? Yeah, I'm thinking about that. If we don't have any classes, it's this label.
Okay.
Because label is custom class, so add the child need a mesh. So again, we need to do a little bit thing here.
So we need to get the mesh within the label.
Yes, and yeah, you can use public here, or even just don't use public. By default, I think it's public, right? Yes. Mesh. Okay. Then again, this dot mesh equal to. So it's the text plain here, right? Oh, size. Font size. the abstract mesh here. So the child of the hello mesh. Sorry, hello sphere. So it's kind of like when you have the get child mesh down here, that will give you a array of meshes. I mean, array of child meshes. So basically, it's adding the mesh into the array.
Yeah. Okay.
All right. So we have the second mesh component here. Right? So we have the hello sphere, right? Okay, we can have hello sphere. You can new. It's the class called hello sphere. Okay. So we have the name. We just name it hello sphere. Okay. Then we have the diameter here. This one. Okay. All right.
Okay, it's there, but it's huge.
Yes.
Covering the whole thing.
Okay. And we can set the position here. I think we can have 0 and 1. I don't know, and 5. I think I put everything just okay. All right, everything is working. So next thing we will show how to implement interactions. So first of all, let's start with the simplest one. Okay, there's 3 different ways to implement interactions. So one is using the behaviors, and one is using the actions, and the third one is using the observables. So that's the 3 different ways provided by bimanual. Bimanual have quite a lot of classes to help you build interactions with these 3 ways. And we do have a fourth one, and it's coroutine. But coroutine basically it's more advanced way to write code for interaction. So basically, it's kind of you just more about you to create your code logic to implement the code. And also it can be used with the other 3, and we can show this later. Okay, so the first thing, okay, so we can use the simple sphere here first. Okay, maybe it's a bit after this. So we got all the spheres, right? Okay, so here we have interactions, right? Okay, so first we use behaviors. Okay, behaviors. So first let's use the pointer drag. So suppose we want to drag something. Okay, so basically we can use a point. The pointer can be a mouse, and it can be a input from touch screen, and of course it can be input from a VR controller, even hands. Okay, if you have hand tracking enabled. Okay, so we need to create a pointer behavior. Okay, we just call the point drag behavior. So this is the functionality provided by the bimanual. Okay, behavior. We can create new point. Yeah, I just use the class name to name the variable. You can just make a better variable name. So basically, maybe just here we can look at the signature. So the options here, so we can define either a drag axis and or a drag plane normal. So if you are using the axis, just basically just drag the object along that axis. So we want to move the plane on a plane, so it's kind of 2D movement, right? So basically we can just use drag plane normal. So basically we give a normal vector to define a plane you want to drag the object. So basically we can use the normal vector here. We can use a method from the vector 3. It's called app. So use the app. vector. So yeah, so in right-handed is basically up is Z. So we just sorry, up is
Y.
Y, sorry. So it's moving the sphere on the X Z plane. Okay.
So this simply gives us the vector 0, 1, 0.
Yeah. You can you want if you want to use 0, 1, 0 is the same.
Okay.
Okay, so let's see. So this create the
And once again, the way how this argument works is that we are providing these options anonymous object with varying optional attributes so that the function pointer track behavior knows what to generate for us. Yep.
Okay, so next thing is pretty simple. As long as we have the, of course, they have other configuration. So the thing is, we can just simply add the behavior here. So add the behavior. So we got the point drag here. All right, as simple as that. That's the, let's try. Okay. I hope
The
this will
moment
work.
of truth. Oh, wow, okay.
Oh.
So it moves in a certain way. Is
Yeah.
that what we expect?
It's actually moved the way we expect.
Okay.
And it's not
So-
obvious because let's add the ground mesh there, so it's you can see it's moved
yes, we can see
on the
that.
plane, right? So
Yeah.
it's better to visualize the result.
Okay, so just to reiterate, we gave it a drag plane normal of 0, 1, 0 or the up vector, which means that it is a plane that is pointing upwards, which is what you saw, which is basically, you know, the like the ground if we look at it from a side view, right?
Yes.
Which is why you see how we drag the ball, it moves in this manner, like dragging along the ground.
Yeah. So okay. So let's create a ground so you can easily see it's working. Otherwise, it's hard to tell whether it's
Okay.
it's working or not, right? So first we create the ground. So in this tutorial, we'll provide the texture. So we will use a ground texture. So it's a grass ground. Okay. So we first create the material. New standard material. Okay. Ground material. And we give the same. And then we ground. Do we need that? Okay, doesn't matter.
Yes, remember your back face culling.
Do we need that? Do we will see? Maybe cut that, right?
Yeah, I mean, we don't need to see that.
Okay, yeah, depending on your requirements, it's really okay. The texture, how is it? Diffuse texture. Diffuse texture. Then again, we will load texture here.
Good. I'm a bit sick of looking at gray solid textures.
Okay, so again, so we already copied the assets there, so we will provide that on Slack, so you can download the one. So this is the texture we are using. So it's a green grass. And
Yep.
okay. Okay, so we give the path assets textures grass, right? Okay, grass dot p and png. Okay. And also give the same. Then we create the ground mesh. So again, we can rely on the mesh builder. Create plane. This ground. Then we got the optional, not option, options object.
Yes.
So we give
options object with a lot of optionals inside.
Yes, all the parameters are optional. So optional options with optional
Yes, indeed.
parameters. Okay. We can define width and height, or you can give the size. We can just, I don't know. We can just try this out.
Yeah.
Okay. We can just maybe 12. Yeah. Oh, I always define width and height, but if that's thing, I think the size will be another option you can use. But anyway, you can try out by yourself.
Yeah, let's keep it minimal.
Then ground material should be the one we have created. It's there, and we
Yes.
need to adjust the
It
the
never
position.
never works the first time. It's graphical programming.
Yeah, that's why it is so nice to have live reloading. You know.
Did you want the ground to be on the XZ plane instead?
Yeah, sure. Yes. Ah, okay. I see what I. So instead of using create planet, there's a function here. It's called create ground, I think.
So create ground would by default put it on the exact plane, I guess. Yeah. Okay.
Yeah. No, it's right.
Okay. Or you could have rotated around X.
Yeah, I can
when
make
you
that by
use
yourself.
create plane. Yeah.
Yeah.
Okay.
Create a
But this
plane.
is just much easier.
Yeah. Otherwise, just rotate the plane to make it like ground. So it's not really. Okay, then we can see. Yeah, it's really move on the ground plane, right?
Yep. Very cool.
Okay. So that's the one way we use. So you can check out the documentation. There's quite a few behaviors you can use, made by Babin.js. So let's see. It's also provided quite a lot of configuration. And you can try it out by yourself.
So this particular interaction, pre-made interaction, does it only work if the mouse is on the ball, or rather the pointer is on the ball itself?
The point, the input source for the point can be from different device.
Yep.
Can be mouse. If it is a non-VR session, it can be from a mouse.
Yep.
Okay, we are using VR. So if we use the simulator, okay, probably we just want to shoot a single one. Okay. So this is a carbon no buttons here. Okay. We can to use okay, so we can try out the here. So it's also have a pointer from the controller.
Yep.
So if we make this one point to, okay.
Wow. Okay. That's.
Then squeeze button is the trigger. So just basically pull the trigger, and it's supposed to just move with the.
Okay, that's cool. Okay.
Yeah.
So this is actually cross-platform.
Yeah. So if it's touch screen, so it's the input from the touch screen. Yeah. So it's a pointer.
Cool.
Okay. So and this will be the next topic. Is we will talk about the observers. Okay. So so basically behaviors are built on the top of observables. Okay. So feel like the BAM.js just the observable is basically the observer design pattern. Okay. So the behavior is built on top of the observable. So basically the behavior class have multiple observables. So whenever something happens, the observable will fire event, and you create create observer to monitor these events and react on these events. So okay, so for the point behavior we have. Okay, if we want to create a observer on some observable, okay, so basically you can call this if they have drag observable. Sorry, it's called we have start. So if the drag start, you can do something when this is start. So the syntax here, you can add a callback function here, and it will use this callback function to create a observer.
I see.
Okay, so it will give you the event data here. So okay,
so let me guess, you're going to write an arrow function.
Yes. It's pretty common to use an arrow function here. So we can just log out the say okay, it's drag.
It's extremely useful for debugging.
Point you can see, okay. So we can have the import from different points. So you can just show the point ID, okay. Okay, so we can get the point ID. Okay, current. It's called current point ID, I think. And also we can also console log out the event data itself. We can see what's here.
It's like Babylon updated.
Okay, yeah.
Updated current point
ID. So what should I use? Okay, use current dragging pointer ID. So.
Okay.
Oh, okay, they just changed the naming. Okay, then just oh, okay, sorry. Should be I. Okay, then it's happy. Okay, so whenever we drag this, you can see when it starts, it will give you saying, okay, that's the point ID, so 1, and also we have the data here, so you may.
Oh, it's not whole event data as well.
Yeah, so that's the event data. Like the event data also have a point ID. So instead you using the behavior, because the behavior here is available, yeah. So you can actually get the point ID from the event data too.
Yeah, I think that's the usual thing we will do, right?
Yeah.
That we will get information from the event data.
Yeah, so instead of they can event data, can point ID does the exact same thing. Yeah, I just use the behavior here just show you actually can, if the behavior itself is available, you can actually get the thing from different source.
Okay.
Normally we get that from event data. If that's not available, you can get it from somewhere else.
Okay. All right.
Okay.
Yeah, I think we can move on.
Yeah. Okay. Yeah.
So there are other events that you can sort of observe.
Yeah, there's quite a lot. So you can just figure out what use of these things depending on your sorry. Let's just quickly show the if press on, then you can see on drag, observe, on start, on end, or quite a lot. Just it start with the on. Okay.
Yeah.
Okay.
Like for example, if you want to show a trail of particles, right? When you're dragging, then you can, use the while dragging big event.
Yeah. Then some code here like start. Do we have the animator here?
It's fine.
Yeah. Just you can have a method here or function here. Start animation something like start something, right? Start something.
Yeah, if we show that, it will take too long. Yes. Okay.
Okay, so next. That's behavior.
Yep.
So next thing we can talk about the
another way of implementing interaction. Okay.
Yes. Let's see. Let's talk about the action first. So okay. Then we go back to observables.
Okay.
All right. So now I think there's quite a lot of code here. So I will make some use of the hello mesh here. We can have the custom class, so we can make this custom class called hello sphere to have some default. Okay, for example, if we want to declare a public method we want to use here, so we can basically, for example, we can say there's this syntax here. So we can have say hello and method here. It can be optional. Okay, then the syntax here is the return can void. Okay, this is how we declare a method. Okay, on the interface. Then we implement that. Yeah, so this is just example how you add a method. Okay, with interface. Okay. Then instead of the not inside the constructor, it should be say hello here. Okay, so I'll say hello. Okay, so we got a message from there. Okay, so this is the way we add a public method on the object. So we want to create the say init actions. Public init actions. We can have private. Okay, they can be used in the constructor. We can make it public. Okay, or make the private. That's depending on you. Okay. Okay, suppose we just make this private, so it just use the constructor to initialize the action. If you want to take some parameter from user or from the somewhere else, then you can make this public.
Okay.
Let's see. All right. Okay. Wait. Action manager. Remember, because this is a subclass of abstract mesh, so we can get the parameter here. Sorry, the property here from the abstract and mesh.
Okay.
Even it's not a part of the interface. Okay, then we equal to new action as action. Then we get the scene. Okay. Remember, we have a few here, so instead of pass the scene everywhere, so we can just use the object property here.
Yep.
Okay, so action manager dot recursive. Yes, because we have a child mesh, so we do want to our child mesh respond to the action. So it is true. Okay. So we have many different actions here. So first we can adjust the action to adjust the light. Then okay, according to the event, some event, we can use the a pick event. So whenever our pointer pick the object, pick the hello sphere, so it will change the light of the scene. Okay. Okay, so first we need to get the light. Okay, so because we use the default lighting, so we can get this one from the scene. Okay, get light by ID or name.
How do we know the ID?
Yeah, so for the default one is named as default default light. Yeah, if you create your own light, you can give a unique name. So like point a spotlight or ambient light. Okay, that's why give a unique name is very important.
Okay, so I think the spell checker just flagged your spelling.
This is the search, the Wing search.
Yeah, I thought it was wrong. From my angle, yeah, I cannot see properly.
Okay, then we just adjust the action here. Okay, so we have multiple different type of actions. So interpolate value action. So this will do the thing for us. So we just gradually turn down the light. So we're using this action. And so next thing is the trigger. Okay. So there are many different triggers there. So we can choose pick pick trigger. Okay. The next thing is the target. So we want to do something on the light. And the property. So it's a bit like you will notice that the syntax is a bit like animation. Okay. Right.
Yep.
Okay, so that's the property we want to control or manipulate. It's diffuse. Okay. Then we want to gradually change the color, okay, to black.
Okay.
And that's the duration in 1 second.
Okay.
All right, so that's the one we have. Action. Way. It's the hello sphere, right? Okay. Okay,
Very
turn
cool. Okay.
off the light.
Yes. Or
Yeah.
actually, you are changing the light diffuse color to black.
Yeah.
Okay.
I feel like to turn off but the UI not really be affected, just only the
Yeah, whatever is affected by lighting.
yeah. Okay, so another features here is the actions can be chained. Okay, so while you complete the first action, you can chain another action after the first one. For example, if the first click will turn off the light or turn the color of the light to black, if we want to change back, so the second click will change the light to be the previous state. Okay. In our case, it will be changed back to white. Okay. So you can basically
copy the whole thing.
Not copy, just put the you can using the content. Okay. Yes, you can do this. But the syntax here is then you put the code then here, then create another action here because
it means we can infinitely chain the then as much as we want.
I think so.
Okay.
So as we change this back to what?
New interpolation.
Yeah.
For the registering action.
Okay.
Yeah.
Which is method name, but actually it's not a promise. Yeah, it's a bit confusing. Yeah. Okay, then you see. Okay, then I click again.
Okay, that's very cool.
Yeah, so this is one thing you can do with the actions. All right, so anything.
And remind us again, how did this get triggered? As in, where does it register the click?
Here is the
event. On pick trigger, I see.
Yeah. So basically, you want to adjust the here. When you make the action here, it will have the option, which means basically it's the kind of event name. So what event is triggered, then it's based on on pick trigger means the pick event is triggered. Then you do something. Okay.
And just to be clear, this pick action is also cross-platform, right?
I think so. We can try.
Yep.
Need to
so we need
rotate a little bit here.
Point it. Yeah.
Oh. Maybe use mouse in there.
Why does it bounce back?
Because the touchpad.
Oh, because the touchpad. Okay, I see.
So let's see.
Okay, it works, but only on release. The pick is actually when you release the button.
That's weird.
Yeah, so it's on release.
Okay. On pick trigger.
I guess the default for pick is triggered on the release of the pick.
Yeah.
Okay.
Okay.
At least we know.
Yeah. You can try to change other triggers here.
There are others.
Yeah. So just make sure you use the right trigger.
Yep.
All right. So they're similar. I think you can also do scaling. Right. So let me see.
Other than light, what can we
If you want to
do?
scale the sphere here, so here is the thing is the you can also give conditions, okay, to the action. So it's not really only depending on the triggers. You can also give custom conditions. So based on the state, it can decide to execute the action or not. So the next example here is you can use an action manager with just another action here.
Okay.
Okay, then we use the new interpolate value here.
Okay.
So again, it's use the manager dot. We can use the send on pick. Do we have other on pick down? Okay, the pick down. We can use you pick down.
Okay. Just now was pick up.
Pick down and pick up, right? We can pick down and we can choose and we can change this on pick down. Okay. Yeah, we're gonna try this. Okay. We can pick down and we want to scale the sphere, so it's this. Okay, this refer to the instance. Okay, because this is inside the hello mesh, so this will reflect to the
Abstract mesh.
yeah.
Okay.
Okay, so this scaling property, it will do. So we will change the size to 2. Okay, vector 3 and 2, 2, 2. Okay, and in 1 second. Okay, so we can pass the predict condition here. So we can create a condition here. Okay, so the first is the action manager. Okay, then we will have a callback function work as to return true or false. I mean the condition actually.
Okay.
And we don't really need any parameter here. So basically, we can return a Boolean value and from a condition. So if we set we diffuse this, sorry, not this. Oh, sorry, the light diffuse. So basically, we only trigger this action when it's black. Okay, so our sphere will magically, grow when it's dark. Okay.
Okay.
Equal to color black. It's like it just grew bigger and bigger like a magic bean. Okay, at night.
Okay. And only if it is black.
Yeah. Okay. Let's see how it works. It's a magic bean, so only grew at night. Okay. Okay.
Cool.
Yeah.
So if it is white, it doesn't. Okay.
Yeah, it done. So if it's black, it will grow and become bigger. So next will be an action, a kind of like a collection, not collection. So it's like an intersection. So then the action will trigger the when the sphere is intersecting with another sphere. So that's when we move the one of the sphere. So it will, if it's close enough, will trigger the action. Okay. Again, action manager adjust actions. Okay, so first we need to have another mesh. So okay, we can see it's intersecting with other mesh. So we can just get the mesh from the thing. So get mesh by ID or name. When you give the name, it also will create ID. So it's the same. Most of case the same. How we name that one? Do we name just sphere? So basically, so now we have the another mesh. So we will check if our hello mesh is intersecting with this the other mesh. So we need to create a new action. So let's see. For this one, we will use another. It's called set value action. So it's just directly set the value of something.
Okay.
Okay. So basically, and we set this to true.
Okay, you wanna explain what you just typed there?
Yeah. So basically, just create a new action. It's called set value action.
Okay.
And then the first object is the trigger option object.
Okay.
So basically, I give the trigger name. It's a intersection enter. So when it's intersecting with another mesh, it will trigger the event. And we give the parameter here. So you give the other mesh you want to check the intersection with, and also you can use precise intersection, or by default it's false because it's expensive.
Yep.
Yeah, you can just turn this on if you want to more precise result.
Otherwise, you will use some form of bounding box or more cost level.
Yeah, I'm not sure what the method they are using, but yeah, to be honest, I didn't check the source code, so they didn't mention in the documentation, so I do not know. Then the next thing is after the option here. So the next parameter is target. So the target is our mesh's material. The property is the turn the wireframe on. So we just set the boolean to true. So
it's interesting that this set value action has quite different argument syntax than the interpolate value action.
Yeah, it's actually the same. There's so you can see the trick option is any. It's any. So you can directly pass the trigger. It will use this as a trigger, or you pass object, then give the trigger the value to the trigger property. So if you want to, so this is two kind of two way to pass the option. So if you have more than one option, you just pass the object. Otherwise, just give the trigger.
Okay, I see. Thanks.
Okay, let's see if this is work. Okay. Oh, this is going to can unmove display, and we don't have. Okay, maybe we just quickly create another behavior. So, all right. So another nice thing to have a subclass of abstract mesh is because you can have the add the behavior method from the superclass. So we can simply add another behavior. So let's see. We have drag behavior for the simple sphere, so we can also add a behavior and to the hello sphere. So here, maybe just use use behavior here. Okay, so here we can have another behavior. So maybe we call this hello. So this time we want to move on the XY plane. Okay. So we use the
forward, backward.
Well, or backward, it's the same, right? Maybe Okay. Should be this one. Okay, this is spheres. This is hello sphere. Okay. So here we have the add behavior. So you don't need to define the add behavior. You can get that from your super class. So we just get past the hello drag. Okay. Nice. Okay. Okay, then we can see it's always working, right? Then if we just go here.
Cool.
Okay. Yeah, so if we're intersecting, then it will change the color. Oh, sorry, change
Into
the
wireframe.
yeah, into wireframe. So yeah. The bimanual just that consider its entering intersection is cut quite a part of the sphere. It's kind of half of the sphere. Then it just start to
I see.
fire.
Yeah.
It's not like a collision actually. Its collision is kind of the bounding box is and collide with each other. It fire the trigger trigger the event. But for intersection, it's a bit different.
Yep.
So this is a bubbling just when they fire the intersection trigger.
So
The event.
one quick question is, is it possible at all to implement the drag behavior with just actions?
Not really.
Depends on what trigger it has. Right?
Yeah, you can. Basically, if you trigger something like, for example, this sphere is a controller object. When you close enough, when it's intersecting with this small sphere, it can use the action to set the parent of this one to the controller. Then you can move the sphere with the controller together. Then kind of it's like you can freely move and manipulate the small sphere with the controller. So it's really depending how you use the action. Yeah.
I see.
Yeah,
okay.
we'll have an example when this small sphere, I mean the simple sphere attached to the hollow sphere. Okay. And also we will demonstrate how to attach a sphere to the controller.
Okay.
But how we will show how to use observables to attach the small sphere. But I think it's also possible to use actions. All right. So okay, we have one final action. So another action, I mean another event you can trick action is we can use keyboard. So okay, we can use another. We can implement another action here. So all right. So okay, let's see. So if we want to receive inputs from keyboard, for example, if I press R, then it will reset the hollow sphere to its initial state. Okay. So this means we need an action manager on the scene, because only the scene can receive the input from keyboard. This is what I learned from the documentation. So basically, in the app, we basically can add the action manager for the scene. So when we create the scene, when we have the lighting, okay, then we can see, okay, scene dot action manager. Yes. Okay. Execute. You can have more complex action. So basically, this is you can have more complex code here. Okay. It's kind of like okay. So let's see.
Okay. So
all right. So it's reset sphere, and this should a message here.
Okay, you want to explain what you just did there?
Okay. All right. So now I just adjust the action to the scene's action manager, and use the execute code action here. So basically, its trigger is on the keyboard. When I press R, it will call the callback function here. So basically, just reset the scaling and reset the wireframe here, and log out the give the message to the console.
I see. So this allows you to execute some custom callback function.
Yes.
Okay.
So it's more flexible if you want to have some.
Let's just pause the recording here.
Okay. Okay. So it's working. So this is all the example we will show here, but there's more actions you can try out. Okay. All right. So we covered the pointer keyboard, and you can also readjust action on the scene's action manager. Okay. So next thing, okay, yes, we will use observables. Okay. First, we can create because actually we already use the observables. For example, on the behavior itself, you can see there's drag start observable. So this is created by Bubbling.js. So we can create our own observables. Okay, so I will show how to create our own observables and find the event we will define. Okay. Okay. So I will show two examples here. So first example, I will use observable to recreate the behavior. And it's hard to say. It's not behavior. So to recreate the action. So the result of the interaction of the intersection, which we use. We implement use actions. Now we implement it with observable. So we just want to show this. Actually, you can achieve the same thing using different methods. Okay. All right. So it's really depending on you which one we want to use. Okay. So after use behaviors, we also have actions inside the hello sphere. So here we will use observables. All right. So first we need to create observables. Okay. So the first one we will create all right. So follow the naming convention. We just name the observable with on. Okay. So we say it's on intersect. Okay. Then it's new observable. All right. It's a generic class. So you need to give the type. So should be Boolean. The type here, I will show why it's Boolean here. So when we have the observable, so next thing we need to readjust this observable to the update loop. So the update loop will check if the condition is satisfied, then it will fire an event that we will define in a callback function. All right. So basically, we will show scene. Okay, they have two ways to readjust the callback function. So one way, I show the way, one way first. Okay, then we show another way in another observable. So it's readjust. It should be before rendering. Okay, so this one will readjust a function. It will call before the renderer to produce the next frame. Okay, so it's basically it's a kind of like an engine. You just update everything, then generate the frame. Right. Okay.
Yeah.
Okay, so I just if instead of the arrow function, well, we show a normal function. Okay, how we use a normal function as a callback function. Okay, inside that. Okay, so basically we we can have a variable here. It's called okay. So basically, we will check if the sphere, the simple sphere, if it's intersect with another mesh. So intersect mesh here. Okay. So if it do really intersect that, with the hello sphere. So precise. Yes, we want to precise. Include descendants. Yes. Do we need? Yes, it's abstract. All right. Okay. When it's true, then we'll notify this one. Okay. Not really when it's true. It's just notify the observer the value. Okay. Always get the value. So let the observer decide what to do, depending on the value. So that's why it's we put type boolean here, because it will notify the observer with a boolean value. Then the type here should be boolean. Okay, because you can notify with different type of object. Okay, so it's a generics. Okay, so intersect observer. Then here is notify. So it's kind of the event-based system here. So it's a notify with the boolean value. We name it is intersecting. Okay. Why is because there's two. They should use this one. Okay, this one will notify all the observables, because one observable, sorry, all observers. Yeah. Okay, sorry. So because one observable can be observed by multiple observable observers. Yeah, okay. Sorry.
Yeah, they should just use broadcaster observable. But
yeah, the same thing. Yeah.
Same thing. Yeah.
Yeah. All right. So when we adjust this function, okay. So every loop it will check this value and broadcast or notify the observers. Okay. All right. So next thing is, so let's choose here. Okay. This is not the it's optional thing. So you can assign the value to the hello sphere in case somewhere else in your code will want to do something, okay, for the observable. Okay. Yeah, because the observer can be at from different time and at different time from different places, so you can create a public property on the sphere here, then give the observable to that property, so it will just like what you will do for the behavior here. So you can just use the onObservable.add to create maybe different observer sometime later. Okay. So to do so, we want to do here. So okay, so back to the interface here. Okay, so again, so we can see intersect observable. Okay, so this should be observable building. Okay.
Your
oh, I haven't
class.
The class, yeah, I haven't implemented that one. Why it's not? Can we just get the
copy?
Not we can
implement everything here.
Where's it?
Maybe at the end.
I don't know. Where's it? Okay. Let's see if we have the stick.
Just manually copy.
Okay, it's put here. Maybe just. Sorry, I think the auto completion is not good enough.
Yeah.
Okay, here.
Okay.
Yeah, so you can define the observable here. So we can here equal to this one, right? Yeah. So and also all this part, put here in the app.ts, but all this part can be inside the hello sphere. Yeah, the class definition. Yeah, you can do this. Maybe it's a better place, but I just put everything here. Just make the flow of the tutorial is kind of simpler. Okay, then this next thing we will just create a compare function, then pass it to the add method. Then it will create a observer. Okay, then the observer will call the callback function when the event and give the right state of the the oh sorry right. So okay, right. So let's see here. What we do is so the action here, we change the material to turn on the turn to okay wireframe. So now we want to see some a bit different. So when the action will set the wireframe, so the observable for intersection will change the color. All right. So okay. All right. So this one we can use the add when you add its callback function, right? So basically, it will pass the whatever value you when we adjust here. Remember, we notify all observers with this value, so it's actually will pass this one. I just use the same name, so make it's intersecting here. It can be different name. I just put here, so it's kind of more clearer. So it will give the Boolean value of the intersecting state. So it's depending on you to do this. So the inside callback function we will first we want to do something and material hello sphere dot mesh. Okay, then we got the material. So we cast this to standard material. All right. So okay. So we can define here two colors here. So we don't need to recreate the right. Let's see how it works.
Okay, that was a lot of code that it just wrote. Let's see if it works.
Okay. And
intersect. Okay. Change color.
And okay, there's okay.
Okay. So you want to explain that
Yes.
chunk of code that you just wrote?
Okay.
Yep.
So the result is the observable will check if it's intersecting. All right. So if it's due intersecting with the simple sphere, it will turn the color to red. It's move far away from the sphere, it turn the color back to white. Okay. So this is how we achieve this result. So basically, yeah, I just created two color, red and white. So instead of create a new instance of the color, I just created these two. Then switch between switch the color and the material color between the two, depending on the state of the intersection. So here I call the add method pass to pass the callback in here. So we get the state of the intersection from the observable and the notifying method here. All right. Okay, then we get the material. So here is the type casting. So because the material is the type is abstract material, I think, or just it's just superclass. It's just it's the class, and it's kind of like abstract mesh. So it will to cut down to its subclass to standard material, so we can get the diffuse color of the material. So here we can check if the diffuse color is already red or not. So then we use the if and if else here. So basically it's a checking. The first thing is check if it's intersecting with something. And then also the next thing is we need to check if it's already red, because we don't want to change the color again. Because if we don't check the color, so purely rely on is intersecting variable here, so it will change the color to red again. Okay, so basically we just need to change the color where if it's not red when it's intersecting with other sphere. So the next one is the same. So we check if it's not intersect, and if it's red. So if it's not intersecting and it's red, then we need to change back to white.
Yep. Okay.
So yeah. So yeah, you can have a simpler version if you just don't check the color.
Yep.
Just kind of if you check the color, I feel like it's more efficient. So you don't need to change the color again. If it's already red or already white.
Okay.
All right. So this is one. So basically, it's achieved a similar result using different way.
Okay. So which means to say we can do this interaction and the behavior entirely using actions, right?
Yes.
Um,
Is that exactly the same? You can see the wireframe works when it's intersect, but it just not change back. But you can
still write more code using the actions code pattern, right?
Yes.
It's just that you would have to conform to that actions code pattern if you want to use that.
Yeah.
Whereas here you are a bit more free to write it in your own manner.
Yes.
Okay.
Yeah, so this is more
Okay.
flexible because you have your own code logic there. But for actions, there's a pre-defined like actions. So you need to follow their their style to like a chain action, something like that.
Okay.
Or you can use the execute code action. That's a more flexible one, but just different syntax. But you can achieve the similar result.
Yep. Okay.
Okay. The next thing example is I will show and create a observable based on a distance. Okay, so this is uh, just purely on our own code. I will not really use any method. Okay, on the object. Okay. Then just create the comments here and observable or on this. So this time we will broadcast or notify the distance, so it's a number instead of boolean. Okay. All right. So let's see. Again, I just quickly to save time. Okay, let's see. So so let's see the result first.
All right.
I basically add a distance change observable here. So basically, if it's close enough to the between the two sphere, it will change the color, I think, to blue.
Okay, cool. That's
and
happening.
then move even close, it will turn to red.
Okay.
Then, so basically, okay, so basically, oops.
Yeah.
Okay. So Yeah, so you can see the blue means the on distance observer is working, and on red, and also the wireframe, it means the action and the intersection and observable are working. Yeah.
Okay.
Yeah, and also if we move far away, then it's a turn from red, turn back to blue, and turn back to white.
Okay.
Okay.
Yeah. And I
Yeah.
think the structure of the code is roughly the same, right?
Yeah, so the
But
code.
the difference is.
Yeah, that's it. Not it's the same. So basically, I create the observable of number type because it will return the
Okay.
distance. So for here, a bit different here is I create a variable called previous state. Then okay, we will use this to see if the distance is really changed.
Okay.
Okay, because calculate the distance between two objects can be expensive. So not that expensive, but we can want to make the program more efficient.
Yep.
So basically, here this is another way you adjust your callback function to the update loop. So instead of remember we have another way. So instead of adjust the function, use the register before render method. Then another one is use the on before render observable. So this is a built-in observable.
Okay.
Then use the add method. So basically we add the observer to that observable. Okay, there are two ways. They're the same, but I just show here you have you have choice. Then basically the callback function here is we calculate the current state, which in our case is the distance. Okay, based on these two objects here, the position here. Then we check if the state has been changed. If it's changed, it will have a log here. So it's saying distance changed, updated. Then we notify the state. Oh, sorry. My bad. It's actually always calculate the distance. The thing we can save some power here, computational power here is you don't really need to notify the state all the time, right? If it's still the same, then you don't need to fire the event.
Yep.
Okay, that's the thing here. Sorry. But we have no way to save anything here because we need to always check out the distance, right? Okay, so far all right. Then here we again to add the distance change observable to the hello sphere. That's optional. Then again, so I create a blue color to indicate it's really close enough.
Okay.
Then we add the callback function here. So we have distance here. Okay. Okay, this add by right here. Okay. All right. So we just check if it's close enough. Then you can change the value here. So just decide by you and have the material. Then have the black here. So we check if it's blue or it's really in red. Then basically the same. So we check if it's close enough. Then if it's not really in any of the color, then we change the color to blue. Then it's move close. Then it's will really far away. Then we check if it's blue. Then if it's really in blue, we need to change the color back to white. So that's the logic here. So okay.
Very cool. Yeah.
I see.
More and more complex behaviors here.
Yeah, you can write your own behaviors here.
Yep.
So next thing is the last part of the behavior and the coroutine. So they have different way for you to add observer to the observable. So the common way here is here. We will add method here, and this one is not observable. Oh, sorry, it's not observer. This is a callback function. The thing here is you pass the callback function to the add method. The add method will create the observer for you using the callback function.
Okay.
So if you really, for example, let's see, you can create your. So basically, you can see the return here. Okay. Okay, it returns the new observer created for the callback function. So if you have some kind of variable here, you can assign the return result here. If we assign it here, you can see it's a observer of number type. Okay. Yeah, so that's one way you create observer. Just use the add method. So it's create and add the create and add the observer to the observable and then return the observer back. Okay, after this method call. Another way is you can create your own observer, then manually add the observer to the observer array on the observable object.
Okay.
Okay, so this is one way. So create observer. All right, so for example, we can create an observer. Okay, I just call this observer. And okay, we can just create new not observable. It's observer. Okay. Then it's a number. We can create a number type. Okay. And here, the first is callback. Okay, so we can just give a callback function here. So basically, we want to create the observer for distance. Okay, and we have. Oops. Oh, it's really okay. Okay. And also, not really. I think that's the mask. Okay, scope. Okay, they have to. Yeah. So basically, you also need to define the mask. -1 should be fine. Yeah, because one observable can have multiple events. Then the event basically have a mask number. So, but our distance change observable don't really have we just file with just one notification. So it can just have a -1, and this is the value I found. Bimanual use one. It's not really mask. Not really use mask.
Yeah, okay.
Yeah, just -1 here. Okay, so then yeah, we just create those. So now we can give the callback function here. And that's fine. We can use the hello sphere. That's okay. Hello sphere, right? And okay, so there's text. Okay, text block, right? Then we have the text, right? Okay, then we can change that to distance. Distance. Okay, and it's a float value, so we should be just do 2 digits. I just want 2 digits. I don't want to have a really long number. Just okay. So how? Okay, we create the observer. So next thing we can add the push the. We have actually there's observers array. This is array on observable, so we can manually push that to the observable. Then it should work. Okay, you see the distance 1.5. Then we x-way. Oh no,
it's okay. We still can see.
Yeah, so if it's close enough, then you can see. Yeah.
Okay.
All right. Yeah. So. Okay. So
Okay.
looks good.
Yep.
Yeah, so we have a label to displaying the distance. So we have one problem here, small issue here. So if we do want to show the distance f, we interact with this sphere, which means that the distance is updated, then we really want to show distance. Otherwise, we just from the beginning we really want to show the name of the sphere, right? Okay. So this is why I'll show here. You can create your own observer and manually push to the array. I mean observer array. Then we can use the coroutine here. Okay. So this is one way we can use. Another way you can set a timer. So, but I feel coroutine is kind of have final control of the bit and the code. So yeah, you can look at the timer from the Developing.js. That's called set and start timer. All right, you can set a timer, then just show the title, I mean the label for a few seconds, and change to the text to distance. Okay, and so what if we just want to not really depending on the time, we just really want to depending on the distance change. If it's really changed, we just change the label text. So this is the thing we can do. Okay, so all right, so okay, so this here we want to do something is add the observer using coroutine. So this is one example, how you use coroutine, and I just explained the syntax for coroutine. So basically, you can create the coroutine first. We can say this add observer coroutine, and it's the syntax here is use the star here and create the coroutine. So this is
fancy.
this is the JS way to create the coroutine. So I just get the code here, then explain later why we need this. Okay, then I press the log because we can control the frame, which frame we want to display which thing. Okay, so I just log out get the log about the frame number, so you can get the frame ID actually. Okay, and let's see, let's add the observer. Okay, then we on distance. It's the observer. Yeah, it's observer array, and we just push that thing. Okay, so this is the coroutine, very small coroutine. We're right here. Okay, the next thing is we need to readjust the coroutine to the loop. So it's just called before run observable, before run observable. This time it's not add, it's called run coroutine async function. Then pass the coroutine. Okay, it's run. Okay. Okay, and we can show this one. Okay. You can see the house sphere, the title, it will be there. It's not really any time limit here. So if you don't interact with the sphere, the title is always there. Okay, unless you click on the sphere, then the distance is updated. Then you actually change the title to the distance. Okay, so this is how we use coroutine. Even I click that, but I don't move the sphere. You can see the title is still there. Yeah, unless we change the distance. When it's updated, you change the title. So it's kind of a more precise way to control the behavior of the label here, instead of you just set a timer. Okay. So for coroutine here, one thing you might have an issue when you use the coroutine here. So if we stop, Control C, if we stop the dev server here and run this again, it will give you something complaint. I think I just have the issue. Do you have the thing? Oh, you don't have the issue. That's interesting. That's great. But if you have the issue, basically you can go to the TS here. Yeah. So because the coroutine syntax is come from the
later version.
Yeah, it's kind of it's the ES6. So you can include the ES6 here. Then it will fix the problem. But I'm not sure why it's not the case here. But anyway, if it's not complaining, then all good. If there's some complaining, just add the ES6 library here. It will solve the problem.
Yeah, I think coroutines is a pretty modern way of implementing asynchronous routines or code. So it's normally in the later versions of languages. So maybe quickly, do you want to explain like what yield does and what happens when you add to or run the coroutine?
Yeah. Okay. So here the syntax, the only difference is we have a start. Whenever you have a start of the function keyword here, it will, instead of create a normal function, it will create a coroutine function here. So you see the signature is a bit different. Here, so in the body of the function here, okay, this is yield. So it's a how coroutine works is like for a normal function, when you call the function, will create a stack, right? Then have all the variable in the scope, then execute the body of the function. Then when it's return the value and remove the stack. Okay, then it's gone. All right. So for coroutine, we have the yield keyword here. Whenever it's have yield, it will return, but it will just pause the execution of the function there.
Yep.
It will not remove the stack, okay, from memory of the function. So, and next time you call this coroutine, it will start from where it was paused. So, which means the first call of the function, it will execute yield here and return, but it will keep the function here, the coroutine here. Then next time when you call this function here, it will start from where it was posted, which means the second line or second statement here, and continue execute until the end of the function, then it return, and then the stack will be removed. So here the coroutine will be called twice. Okay, the first time we will do nothing. That's the first frame. We do nothing. Okay, then the next time it called is the second frame. So if you see the output here, the log here is saying frame 2 at observer, which means we pick the second frame to add the observer. Okay, so this is what the coroutine does. Then this one, we run the coroutine, so which means we add the coroutine to the observable. It's not add to the. Run the coroutine is kind of adjust the coroutine to the loop. So whatever it is, readjusted in the loop. So for every frame, it will be called, right? So for example, the previous one, where's the previous one? Okay, so we have this one, right? So this one is will readjust a normal function to the update loop, which means this function will be called every time. Okay, and the coroutine is similar. It also will be called every time for every frame. Okay, so instead for a normal function, it will execute the whole body of the function. Okay, and the return. For the coroutine, every time it will return when it's have a yield here. Okay, so you can see for our example here, for the first frame, the update root will call the coroutine here, and we will do nothing, and yield return. And for the second frame, it will call this coroutine again, but instead it start from the beginning. It starts from the second line, which means it will give console a message saying, okay, this is frame 2, and we are about to add an observer. Then the third line here is we actually push the observer to the observer array. So then there's nothing there. Then the stack of the function will be removed. So it's truly returned. Then for the third frame, they will not call this coroutine again because it's over. I think that's the coroutine. How it work?
But how does it know in the second frame whether it should continue to yield or it should?
Yeah, it's depending on here, right? So then if we put something here, yield, okay,
Yeah.
for example, here, and we do want to the third line, so this time, okay.
Yep.
We don't really add nothing there.
Another
Do nothing.
print of, okay.
Yeah, okay, do nothing here. Okay.
Yep.
Okay.
Let's try that. Let's.
Okay. Or even we can place the here, right? The first frame, nothing here.
Yep.
Okay, and okay. Okay, we can see for the first. Okay. See the first frame, do nothing. The second thing, take the frame we observe. Then the third one is still do nothing. Right. After that, nothing more. Because every time you hit yield, it will just return, and the function execution of function just pause there. And for next call, it just start from the next line after the yield. Okay.
Okay.
Yeah, so I can have a more quickly. Yeah, I can show a more complex coroutine here just to demonstrate how coroutine works. Here I just quickly get the thing. Okay, and I construct a const coroutine. All right, so I add another coroutine example here. So it's will give you more detail about how coroutine work. So here let's see, I create the coroutine, so the generator. So be aware of here, we instead of pass the variable name here, we have round braces here. So it's actually call this function because it's a generator. Actually, the type here, it's a generator. It's generated the coroutine. So it's basically we'll call this generator to give the coroutine and pass the coroutine actually to the method here. Okay. So basically, for this coroutine, okay. So I create 4 async function here. So then every time. So the first one, okay, I use a tool called a delay. So it's just wait for 2 seconds here, and give the log here, and you return. And then we have a second one, the same thing, but I call this function too. Okay, then we have third one. It's also async function here. It just give the log without any delay, and we have the U here. I'll give the delay to the U. Okay, then we have the last one. So it's function 4. It's just normal async function. So when we refresh page here, so we can check out the log here. So and you see, so this is the first coroutine we use. So we export 1, 2, 3 here, right?
Yep.
Okay. Then we can see the function here. Yeah. So because it is an async function, so it will not wait for this one to return the result. As long as it's called a function, it will just go to the next line of yield, and so for the rest are the same. So it's really depending on when this get the result. So when the delay of the okay. So whenever it's so for this is the first frame, right? So when it's first frame, it will call this function, and this is for first frame because it have to wait 2 seconds, so we will not see the log here. And the second frame, it will call the second function. So basically, the execution of the code is first frame it will call this, then you return. Second frame will call this, then you return. And the third frame will call this, then you return. And the fourth frame will you return. Okay. And not fourth frame. Basically, this is the delay here. So interestingly here is if we put some delay here, it will wait for 1 second. 1 second, then call the false function here. So you can see for the first two, we only have frame 1 do nothing, just from the first coroutine. Then frame 2 at observer, also from the first coroutine. There's nothing here because the second coroutine for the first and the second frame, it's called a function, but the result is need to wait for 2 seconds. We can get the result. Okay, then we got third frame. See, so for third frame here, do nothing from the previous one. Sorry, the first coroutine. Then we have the second log from the second coroutine. It's just saying it's function 3. Then okay, so here we wait for 1 second, which around the 50 frame on this machine. Then we have frame 54. We have the function 4, right? Because it's only need to wait 1 second, so we get the message before 1 and 2. Then the final 2 messages from the function 1 and function 2, which is wait 2 seconds. It's around 100 frame. So we get the first function first, then we get the second function in next frame. So yeah, that's the example here. You can think about how call routine work. So
Yep.
yeah, maybe a bit too much to digest, but you can think about that to figure out how coroutine and coroutines work. Okay.
Yep. And I think a lot of you guys who are from DigiPen would be taking the mobile app development as well, which also has coroutines. So it is the same fundamental modern programming code construct that is pretty powerful, and you can think about different ways to use it, more than just for the purposes of what we are showing here for interactions. Yeah. So
Yeah.
okay.
Yeah. So the example here is more for you to understand how coroutines work and with Boblin.js code. Okay.
Yeah.
So I think we have one more part of the tutorial is about the locomotion. So it's about how you two. One is how you move around in the VR environment.
Yep.
And the other is use the controller to interact with the object. Basically just pick something up and just do something. Okay, so yeah, it's time to walk around. So let's show how you move in virtual environment. So first and to implement there are different ways. So we will show 3 locomotion methods here. So one is use teleportation. It's very common. Another one is not really common. I suggest not you use, but it's available there. Just use the controller to move around. More like a FPS game.
Okay.
So if
I
you
think
use a controller,
we can skip that.
you can skip that. Yeah, it will immediately give you some
Cyber sickness.
yeah, something is, to be
Yeah.
honest, I tried, but just feel like something in less 10 seconds.
Yeah, yeah.
The third one is the bimanual feature called walking in place locomotion. So basically, you just walking in place, and the bimanual will detect the head motion and decide whether or not it's in the state of walking. Okay.
Okay.
Of course, there's another way is that just tracking the position of the headset that move around, but it's enabled by default. It's don't really.
Yeah. That's normally called real walking.
Yeah.
Tracking the real walking.
Yeah, but that limitation because you have limited space to walk around. So the walking space is really good because you don't really move, but actually you just walking in the place, and then your avatar in the VR, then it keep moving. There's no limitation, no limit of the observable. Okay, still a lot high. Okay. Where's the? Okay, here. Okay, so this is XR session. Okay, let's see. So first we initialize the default experience, then we get the XR. So XR is default experience. We have quite a lot of things can do here. So first, here we will locomotion here. So first we need to get the feature manager to enable the feature we require. Oh, wait a minute. We need to let me see. We probably need to enable in case we need that. Okay. Enable these optional features. Then we get the feature manager. The feature manager is from the XR, the dot base experience feature manager here. Okay, it's created by the bimanual's default experience. Then after that, you can print out available and this example, it's available features from the class. So this is all possible features. Sorry, features manager. And what? Web XR features, not features name. Features manager. Okay. Dot get available features. Okay, and yeah, this is all the current available features from WebXR, but not all features are supported by your device. It's a subset of this one. Okay, but you can look at how many that's all the features available from WebXR now. Okay. Right, so allow we get a feature manager, we will have set up the multiple locomotion. So I will create and let's see in I think that's the thing we should do this. Okay, I think it's in here. Yeah, just try to show the more feature we can use with the TS that's in here. We can say teleportation. Okay, I forgot to do it, but let me use that and work. Okay, that's this one. Okay, then we can let me see. Okay, instead put everything in the here. So I will have the convention here. So we have quite a lot of things here. So here we add a method here. So let's do this. I see init locomotion here. Okay, so what we need to use is we need to pass the movement. Okay, movement mode here first. Then we should give the WebXR default experience and give the feature manager WebXR.
Okay, I think we need to use the magic of video editing again to fast forward this.
Yes, yeah, it's quite long.
So
okay, then mesh. All right. In the future, this work should be done by ChatGPT or something similar. Okay, while Check is trying the teleportation, I will explain the code here. So we set up the, so I will create a variable movement and use the teleportation and called init locomotion here. So we can see we use the switch statement here. So the first case is for teleportation. Then basically you need to enable the teleportation, use the feature manager, then give the name. It's use the WebXR feature name dot teleportation. Then the version we just use the stable version. Then we have options here, options object here. So we need to specify the source for the import. So it's come from the XR default experience import here. And for teleportation, we need to give the ground, okay. And the tend to teleport, it's 2000 here, means we if we trigger the teleportation, it will wait for 2 seconds to actually teleport the user to the location, okay. And here using main component only means we just use the trigger, because some controller will enable you use other buttons. So for this demo, we just use the trigger. All right. Then the other options here is for the mesh. So you can see when you use the teleportation, you can see indicator there, right? So here the option just for you to specify like the color, okay, the fill color of the circle, and also the border color, you know, the inner fill color, and also the material you can use for the torus. Okay, now we just reuse the material of the ground. So just you can see the green grass, okay, on the torus. The other things after options, we have also let's see, enable feature, okay. There's 2 boolean value here, so you can check out documentation here. So that's the explanation for these 2. The first one is attach if possible. So we set true, so it will automatically attach the feature, and also we make sure it's using the teleportation. So we set required to true. So this session will require teleportation. Okay, so you can have more configuration after you create the teleportation object here. So like you can enable the parabolic ring, so they can see there are two rays. Okay, one is straight, one is a parabolic, and also can configure the check radian of the parabolic ray. So that's the configuration you can have for the teleportation. The thing we usually to set up. So we'll skip the controller, right? I don't want to make you sick.
Yes, yes.
So the code here is still work. I think it still work. We can show on the maybe on the simulation.
Yes.
Yeah. Okay.
Simulation is good. Yeah.
Otherwise, I
Yeah,
think
we can simulate cyber sickness.
okay. Okay. So okay, let me change the mode to controller. Okay, and restart.
We can also just
Yeah, you can do. And
yeah, not wear the goggles, but we use the controller.
you need to refresh the page, I think. Is
Okay.
that a reload? I'm not sure.
There's no reload it unless we get out of the or we press. Yeah, we get out of the full screen view.
Sometimes it will reload. Okay, I can do something for you.
Okay.
We can...
hot reload in.
Yeah, so
the device.
It's a cron. Like it's inspect something. Inspect it. Oh, okay. If I'm doing is I'm using the default. I can refresh here to see if it's working.
Okay, it's refresh. Can I actually click? Is this the process?
Yeah, it's
okay.
This is
oh wow, this process. So I need to click this. And then okay.
It's a problem actually.
Oh okay. Let me just try and test this.
No, it's not wrong here.
Okay, stop it anymore.
Okay. Okay, maybe we choose when to use reverse or here. Let's see if it's because we change the connection message from cable to Wi-Fi.
Okay, working on.
It's working.
Yeah. Okay, so let's click the screen. Wow, that's so fast. Yeah, the default speed is like really fast. Or is that the speed you set?
Yeah, I think I can set the. You can set the. I think the sensitivity. I guess.
Yeah,
yeah,
so
that's the default one. Pretty quick.
Yeah, the default one is like
definitely will feel sickness instantly. I think.
Instantly, yes. Just trying to simulate.
So, yeah.
Okay, that's all.
This is for movement. So another one is for rotation. So yeah.
Okay, I'll use one hand. Yeah. Do both controllers. Yes. Okay, rotation.
Yeah. Okay. Then then we can try the another one. So it's try the walk in place. So okay. Walk.
Okay. Let me just wear this so that I can try the walking in place.
And then I can refresh it for you.
I can refresh.
Okay. Okay, you don't need to do anything. You just keep walking.
Why am I taking the control?
Yeah.
So similar to what we
Yeah, it's still a experimental feature. So yeah, it's not robust. But if you get used to it, I think it works well. But you do need to have a bit time to figure out the right walking style or something.
Why one of our proposed future work in our study with the LTA commuting is to explore individual sport that provide customized.
Yeah, so okay. We can just explain a little bit here. So here we use the feature manager to disable the teleportation first, okay, because we want to just use the working place. So first we'll create the XR root, so it's a transform node. Transform node is the parent class of abstract mesh. So basically just the node for contain the transformation and information. Okay, then we set the parent of the camera, the VR camera, which is the the view, for the VR user. So then, okay, we enable this with feature manager to give the name of the locomotion. Use the version latest. Or we can use stable. I don't know. Yeah. Yeah, you can choose latest or stable. There are different versions there. Then we just give the target. So the target for the locomotion, I mean working locomotion, to manipulate, which is the XR route. Okay, so yeah, so you enable the working locomotion. So by this way, it's not much there. Of course, there's I think there's more option here. You can just look the documentation to figure out. So we will not show the details.
Okay, so what is next?
Then we can to talk about the interaction using the controller or even hand tracking. So actually, hand tracking was working, right? When you try the locomotion. Actually, let's get back to here. So not all devices support hand tracking. So let's see. Okay, let's see. Const XR hand feature. Do we need that? And maybe not. I think you just enable that first, right? Okay, let's see feature manager. Okay, so first and the WebXR feature name and tracking. Okay, and we let's try this.
Error. Oh, not compatible in the web, right?
Yeah, it's not compatible web. So we can write the try. Right.
Oh. Yeah, it's some
yeah, just application and figure out this disable default and flash.
Oh.
Okay. Somehow,
So there is a.
Yeah, it's tracking the.
Okay.
So there's a multiple mesh of your hand. So it's actually tracking quite a lot. Meshes. Yeah. Okay. If we specifically turn this on.
Cool.
Okay. Okay, now it's working.
Okay, now. Let's see.
Yeah. So I set the. Somehow I just set the disable default hand mesh to false, then it will show the default one. Yeah. So if you manually enable the feature, it will track the joints of your hand. So yeah.
I see, that's very cool.
Yeah. By default it's not tracking, right? It's only track the hand as a one mesh, right? So there's no.
Yeah, by default it's a solid hand mesh.
Solid hand mesh.
Okay. So once you switch it on manually, I think.
Yeah, it looks pretty good.
Yeah, it looks pretty good.
Okay. All right. So this is for hand tracking. You can try out if you have the device to support. And there are more configuration for the hand tracking, and we just don't have much time to show here. So you can just you can find these in the documentation.
Yep.
All right. So the last part, I think. Okay. So now we to use the controller hand to interact with the object. So let's try some bimanual interaction, which means we use both hands or both in controller.
Okay.
Okay. So we will implement scaling behavior.
Yep,
So
we'll just
when you
do it,
use when you use both controller or hand to scale the one mesh. Okay. So we have a default behavior, so I can just put that in the behavior section here. So okay, use behaviors. Okay, so let's see here. Okay, all right. So let's see. This is a multiple pointer scale. All right. So let's see. We can create multi pointer scale behavior. New and look at the multi pointer scale behavior. Okay. All right. Then basically, which one shall we make? Hello, let's see if this works. Then behavior is quite simple. I think. I default shall work. Help.
So now I'm trying out the bimanual interaction. So what we're doing here is to show that we can use two controllers or two controls, two control inputs to do an interaction, which in this case will be scaling. So we have two Quest controllers here. As you can see, I'm using one of the controllers to do our usual translation around the XY plane. Okay, and if I use the other controller, I can actually scale it by registering the fact that 2 points are on the sphere using our two different controllers. Just note that myself, I just found out that the default interaction mechanism for the controllers or the display pointer mechanic is such that whenever you click the trigger of one hand, it will switch the control to that hand, and you can see it by the rays. I click on the right, it switches the ray to my right hand. I click on the left, it switches the ray to my left hand, showing that now my left hand has the control. So this default behavior causes some issues when you are doing this bimanual interaction, because like in this case, my left controller is having the control, and if I want to register another point of control on the sphere, I need to click my right control, in which in this case it switches the ray first, and then you need to click again to touch the sphere in order for the second point to be registered. Am I saying the right things, Songjia?
Yeah, I think it's a bit weird.
Default behavior is a bit weird, so you sort of need to code your way around this. Okay, anything else we have?
Okay.
I think that should be the last thing.
Yeah, I think one more thing, and it's okay. Before we show the last part, is
Okay.
okay. So we have more behavior actually available from bimanual. You can explore. Okay, so more behaviors. So we do have it's called a 6DOF drag behavior here. So instead of just drag on a plane, you can just rotate and translate in any direction. So yeah,
Okay.
but we can achieve this using the controller or handed drag feature I will show next. So for pointers, okay, for like for mouse and the keyboard, mainly the mouse are touch screen to do the 6DOF, and it's pretty hard. So the bimanual also provide the gizmos to for this kind of interaction. So I just show a quick way you can do this thing. So we have default. It's just 2 lines of code. Okay, and okay, default gizmo. So basically, you can have a gizmo manager here. Okay, and okay. All right. So there's different gizmo here. So you can enable them. For example, you can enable the position to true.
Okay.
All right. Okay, you can see whenever we click on the sphere, okay, it will display a gizmo for you. So you can drag the axis here to move around.
Well, that looks like a very useful feature, especially when you're creating some UI for the user to shift things around.
Yeah, so if we can also have rotation enabled. Okay, we have two. Like you can rotate.
Very nice.
Oh,
Yeah, the default speed of movement in Babylon is always super fast.
yeah, so it's kind of, and also we have that too is the scale, right? And I just enable the other two, and also we'll have a bounding box. Sorry, the wrong one. Bounding box, gizmo. Okay, so it's help you to do the 6DOF interaction. Okay.
Oh, okay.
So this is the bounding box.
Yeah,
Maybe it's just disable the other three to make it easy.
this looks extremely useful when you just have one point of contact, like gaze control.
Yeah, for Google Carbo it will be, but it's still very hard to use the pointer to point the small dots here. So you see, that's a small dots for you to rotate.
Yeah.
This is a bounding box into drag behavior. This is for scale, and this is what's the it's just, yeah, you can also move around. Yeah, you can try out these gizmos, pretty useful, but I doubt if it's really helpful in VR condition. Okay, and okay, so the last piece we will cover the hand or controller and interaction. Just grab the sphere so you can do whatever you want, and yeah, so yeah, it's kind of a 3DO interaction, but more in a more natural way. Okay.
Okay.
Okay, so we have hand tracking now. Do we have hand or controller? Okay, so let's see. I can just add the code here, then explain later. Okay. We're forward to the.
All right.
Okay.
This one does it work?
Too close.
Okay, cool. It works. Let's move back a bit. Hey, I grabbed the ball.
Can you release?
Yep.
Okay, feels okay.
Yeah, it feels fine. This, although it's just primitives, it feels very immersive. Ball grabbing action, simple thing. I think the last thing is perhaps just give us a brief overview of what you just wrote in terms of
oh yes.
yeah, the grabbing action.
Also,
the grabbing mechanic that you just coded here.
Okay. Yeah. Okay, so yeah. So first of all, this is very not good practice for programming. Okay. So I mean, it's better to break this big chunk of code into several functions. I just try to make this work first. I think I leave the homework for you guys to figure out a better way to organize this chunk of code. Then first I declare a mesh here. So the mesh will hold the whatever a mesh and the pointer. Okay, so first way here is add the observer to the on controller add observable. So which means as whenever the controller is available, it will run this code back and give you the import source. So in our case, it's a controller because it's VR. So then for the VR controller, they also have a motion controller, so it's either a hand or a track the remote controller. So we can just here this the observable is one will be will fire the event when the motion control be initialized. Okay, then when the motion control is available, then we get the trigger. The two way to get the trigger. One is you get the IDs, then you can use console log to get the ID, then give the ID to the get component function a method here, and or if the component is unique, for example, every controller have only one trigger button here, so you can just give the type of the component to get a trigger. But for button here, you have two buttons here, the A and the B, then it will not work. It's better to use the IDs. The web XR, the official website, there's a web page there, have all the information about the different kinds of VR controllers. Yeah, so yeah, so in the on the Babinger's documentation here, you can go to the WebXR import and controller support here. There's a link here. It's called the WebXR import profile viewer. So it will list all kinds of different controllers here. There are buttons. There's the ID of button here. Okay. And also this other information, so you can check out. Okay, you can go back to the code here. So then whenever we have the trigger, right? So we also need to use the observable for the trigger state. So we use the button state change. Okay, whenever the state button state changed, it will call this callback function. So here we check if the trigger states has changes. Then if they have changes, we see if the trigger is pressed. Okay, and then if it's pressed, then we check if there's anything under the pointer. So if there's anything and the pointer, we assign the value to the mesh, but it's always set the value of the return. Assign the return value from this method call. Either it's none, means nothing, or it did have some mesh. Okay, then we check if the value of the mesh is nothing or something. If they do have something, we continue to process. Okay, so here, whenever we have the mesh, we will print a log message here. So we will see what point, what mesh ended point. And if we just see now the pointer, the mesh end point is ground. So basically it will just show you what mesh is end pointer. Now we can see the mesh end pointer is a sphere. All right. So you can see if it's ground, we don't really want to move the ground, right? So we check if the meshing is ground. If it's not ground, which means it's movable. All right. The next thing, we check distance between the motion controller and the mesh and the pointer, because we don't really want to grab something really far from the user. It's really depending on your app. So we want to make it feels natural. So only when you close enough, I mean the controller close enough to the mesh, then you can really pick it up. Okay. if your application is a simulator for Superman, maybe you can just grab things from distance. Okay. Then we print out the distance. You can see the distance is 6.7. That's really far from the sphere. So we do nothing. Okay, so we check the distance. So if distance is smaller than 1, we grab things. Then if this too far from the object, then we do nothing. So if we just move a bit close to the wrong. Okay, so as we move the control really close to sphere and press trigger here. Okay, you see, the distance 1.9 is less than 1. Then we grab mesh. The mesh name is sphere. Okay, so whenever it's grabbed, then we move the controller around. You can see it just follows. Because we set the parent of the mesh to the root mesh of the motion controller. So whenever you rotate or move, the controller, then the mesh will also be rotated and or translated with the controller. All right. And here, this is the log message for if there's nothing at the point. And here, the else here is whenever you release the button here, you can see the else clause is for this trigger dot press. So it's pressed, then we do something for grabbing. If it's released, then we first looking for if there's mesh there. Then also if the mesh's parent then is not none, which means we set the mesh to attach the mesh to some to the controller. Then we want to release the mesh. Then we set the parent to none and give a message in the console saying something is released. Okay, then we just press here. You can see we release the sphere here. Okay, then this is the all the code for controller grabbing and interaction. Yeah, it's better to break this big chunk of code into at least one more function, I think, even several.
Yep. And as you can see, even a seemingly simple looking interaction requires quite substantial code if you want to do it correctly. And when it's done correctly, as you have seen just now, when I was trying to do the grabbing action, it actually feels pretty immersive. Yeah. So with that, I think we've come to the end of today's live stream, recorded live stream. So I guess we set out to cover more than what we have shown today, but I guess due to the length of this video, I think we certainly have to stop here. And I also feel that we have given enough of a glimpse of a range of different ways to implement interaction across a range of different common interaction types in immersive applications. Yeah, so I think with that, we'll end this video and we will see everybody in class. Yeah.
Okay, yeah.
Yep.
Thank you, everyone.
Okay, thanks, Song Jia. Okay, bye-bye.
Bye-bye.